Great. So welcome. We're having our meeting on Goblin construction, on task 1.3 on integration and the linking of knowledge graphs. Today we have an invited talk by Irene Cellino on the first part, and in the second part we have the Q&A and assembly of the task. We're very happy to have Irene today with us, which is going to present about modeling tacit and implicit procedural knowledge with knowledge graphs, a human-centric semantic approach. Irene Cellino is a computer scientist and research line manager at Cherryfield, specializing in semantic web technologies, knowledge graphs, and human-in-the-loop AI. With over 20 years of experience in research, innovation, and technology transfer, she has led numerous research projects and authored more than 100 scientific publications. Irene, thank you very much for accepting the invitation. We are very happy to have you here, and we're very much looking forward to hear what you have to say. The floor is yours.
Thanks a lot, Eleni. I'm really honored to be here. Thanks for the invitation. As Eleni was saying, I'm a computer scientist, but I'm from Appr, which is a private company. So I will take you through this concept of collecting and exploiting procedural knowledge in industrial settings. That is a bit in between research and innovation. So what I'm going to explain you today is what is the problem first. So what does it mean to manage procedural knowledge in an industrial setting? I will guide you through two elements. One is the ontology that we built, and the other one is, okay, given the ontology, how we build knowledge graphs based on that ontology. And I'm gonna finish with some lesson learned from the very pragmatic application of this knowledge graph construction, and also what are the research challenges that are still open for us. So what I'm going to tell you is mainly related to this project named PERCS that I am coordinating. It's a Horizon Europe Innovation Action that started 2.5 years ago and will end in September this year. And while you may be used to research projects that start from a scientific question to be applied, this starts a bit the other way around, because as I said, Cherryfield is both a research center. I am from the research part of Cherryfield, but Cherryfield is also a consultancy company. So we advise companies in their digital transformation journey. So PERCS actually started from some challenges, some unsolved challenges from our own customers. So these are three examples of three different companies. All of three were from the manufacturing sector, different business units, production, maintenance, customer service, that had some sort of similar problem. And the problem is we have to find a way, an efficient and effective way to manage something about how to do things. In one case was root cause analysis. In the other case was step-by-step maintenance. In the third case was how to solve customer issues that the customers came to the company to ask for help. So what those three cases have in common is that they have a knowledge management problem first, and that they deal with a specific kind of knowledge, which is this how-to knowledge. So most of the work we do in the area of knowledge graphs are mainly related to descriptive knowledge. So know what or know who. Procedural knowledge means know how. In some cases also know why, but I will talk a bit less today about causal knowledge, but of course it's related. So given that we had these customer problems that were not solved by current technologies, we decided to go for and build a research project around it. And this is how the PERCS project was born. So the PERCS project has the aim to solve this issue of the fact that this kind of knowledge in industrial settings is very poorly digitized. Sometimes it's not documented at all. On the other hand, for the company to work properly, executing those procedures correctly is of utmost importance. So our target, our final users are the workers of this company that need to execute those procedures. Of course, we want to improve efficiency, okay, but that's a more business side of it. From the human side of it, we want to improve the upskilling and the knowledge transfer. Another leitmotif between different companies is that they have senior people which have a lot of knowledge, and then they have the new hires that need to learn how to do their job. So this knowledge transfer is usually done orally, and having instead digital tools to support all of this, it is the goal of PERTS. So we are building tools for, on the one hand, eliciting knowledge, on the other hand, managing, storing, preserving, and finally, how to reuse this knowledge in practice. And we are doing with a mix of symbolic and sub-symbolic AI, because of course our goal is to build knowledge graphs, because we strongly believe in knowledge graphs, that are procedural knowledge graphs to be used, and with always this human in the loop approach. So of course, PERTS is an AI-driven project, but AI not to automate things, but AI to augment people's capabilities. What is PERTS about? It's about governance 360 degrees of procedural knowledge. We started from asking ourselves, what is a procedure? Then where procedure comes from? How can we model, preserve, store these procedures? And then how to make these procedures available to who need them, when they need, where they are, and so on. And this not only once, but throughout the life cycle, because knowledge changes over time. So we need to keep this knowledge up to date, corrected, and available to everybody. And how we are doing it, we are using, of course, knowledge graph and ontologies as core pillars of our solutions. And we are using a number of other techniques around it, from, of course, knowledge extraction, from text and semi-structured data, to conversational AI for user interaction and the like. Very high level, I will spend just a few seconds on what is the architecture. You can see in this architecture the three pillars that I just mentioned. So the elicitation part, with tools to collect information from people, to extract it from documents, to extract it from semi-structured data. All this information is verified through human in the loop and feeds a knowledge graph, which has a conceptual model, that is an ontology, as a reference model. And we build this access layer, aka a data product, that gives access to the knowledge graph to downstream applications. And downstream application can be very specific to a specific task, or be more generic. In particular, we have things. So one is this intelligent assistant, which is a chatbot that guides step by step in the execution of the procedure, and the question answering again through the chatbot. And we have this auditing component on the top that audits, monitors the entire life cycle of this knowledge. So I could talk for hours about this. Today we'll focus on two things: the conceptual model and specifically the collection from people. I will touch also collection from other sources, but I'll focus more there, because I strongly believe that the human part of knowledge management is what really makes the difference in practice. Let's start from the ontology. We wanted to build a reference model that acts as a sort of lingua franca between all different components to exchange information. So we wanted to build this knowledge. How do this ontology? How do we start? We started from getting requirements from concrete cases. So in the project, we have three industrial companies. You may have heard of them, which provide us very different cases of procedures. In one case are safety procedures, in another case are the procedure for a commissioning of a new machine, in the third case the procedure to manage and optimize microgrid usage. So we had very different requirements, which had some things in common and a lot of things different from one to the other. But the idea of getting requirements from such different cases was to build an ontology that could be transferred then to other cases. And as I will tell you later, this actually happened. So we build the ontology from concrete requirements. And we did it by following the LOT methodology, linked open terms methodology. You may be familiar with that. I will not go into much details, but just to let you know how we did it. We had this hands-on collaborative workshop with the mirror board to collect requirements. Then we built competency questions and facts, as usual in ontology engineering. Then we went through cycles of validation and rephrasing and redefinition with, again, the use cases. And this helped us in having the actual requirements for the modeling. Then, of course, we discovered that actually our scope was pretty wide. So the first step before starting to draw classes and relationship was to understand the conceptual areas. And in this case, we identified, of course, the area of the procedures with the attached resources, assets related to procedure, the internal structure of the procedure with the steps and the characteristics of the steps of the procedure. Another thing that, for example, is mostly missing was mostly missing in the state of the art was the distinction between the procedure and the execution of the procedure. So the actual instance of executing a procedure in a specific case. Then there's an area about the agents that either execute or define the procedures, which are, of course, different agents, and all the stuff related to this idea of life cycle, so change of status, evolution of the procedure over time. Finally, we started with the actual modeling. So one key learning for all of you is don't start from drawing classes and relationship, start from the requirements, because if you already start from modeling the classes, you may miss a lot of important details. So we started from modeling, and of course, as a good practice in ontology engineering, we went through the state of the art to understand which ontologies to reuse, and we reuse actually a number of them. Some are very generic, and you may know, like DCAT, DC terms, or Provo. Our main concepts are taken from P-Plan, which is a planning ontology that defines plans that are pretty similar to what we intend for procedure, steps, and so on. But we, as you can see, we reuse a number of different ontologies. The result is this, that you can easily read, right, from the diagram, which is PICO, Procedural Knowledge Ontology. You can find it online. There's a paper that describes it in very details. We published on the web, as usual, according to the best practice for publishing ontologies. We have a GitHub repository, we have permanent URI, documentation with Widoko, releases on Zenodo, of course, an open license. So what is the content of this PICO ontology? We model the procedures, their execution, the resources, the agents, all the provenance about everything. Our focus, our scope, are procedures as they are understandable by humans. So it's not a generic workflow or a generic process. We focused on this specific kind of procedure because that was the requirements that were drawn from. So procedure in which at least some steps are executed by people and people need to understand what's going on. We, as I said, we draw the requirements from our 3 industrial use cases that I mentioned at the beginning. But actually, every time we presented PICO in a conference event and so on, we always receive questions like, oh, I have this other case, can I use PICO to model this? And lately we've been, I mean, every week somebody contacts us through LinkedIn to ask for guidance on how to use PICO. So if you want to know more, there's ESWC 2025 paper online, and since my colleague Valentina presented at the conference and the video lectures recorded it, so if you want to know more, there's also the paper presentation. Okay, we have the ontology. Now, that we have the model, we want to build the knowledge graph. And building knowledge graphs about procedures is not that easy because of this idea of having tacit and implicit knowledge. So first, I will make a little distinction because some people use tacit and implicit as an interchangeable, but they are two different things. Tacit comes from Latin, means silent. So it means something that is not expressed, not documented. So tacit knowledge is what people have in their hand. If you want to elicit this kind of knowledge, you have to ask people. And as you may have experienced from every time you ask a person to tell you something about something, they have their own conceptual model, they have their own perspective. So in order to collect this procedural knowledge from people, you need to guide them on what you really need to know in order then to make it possible to express it in Pico and put it in a knowledge graph. The other side is the implicit knowledge. Implicit means that there is some representation, but this implicit representation is not fully explicit. For example, it can be embedded in text or in tables or in images. So you need to extract this knowledge. And of course, there are lots of knowledge extraction technologies. And that's what we did. So we use AI to extract this knowledge from those formats. But then we need human in the loop. I will explain a little better why in the next slide, but the idea is that, okay, you extract this knowledge, then you have it validated from humans, checked, and so then only then you put it in the actual knowledge graph. And this is also used because there is, let's say, a bonus step. Once you have this validated knowledge, you can feed it back to the AI to improve its accuracy and also improve the extraction pipeline. Okay, so what do we, how do we extract or collect this tacit knowledge from people? We build a tool. The first tool that I showed to you is a very generic tool. The link on the top, you can see there is a demo available. It's a web form that behind the scenes hides the translation of what the user writes in the form into an actual RDF representation according to Pico. So this is a web form with fields, drop-down lists, buttons, and everything else to guide the user through this compilation. And the output is then translated into RDF according to the right model. So to ensure that the output can be used and integrated with other knowledge with the same format. Is this enough? As you can guess, of course, no. What is really needed whenever you have real users is to customize tools in order to make them usable for the actual people, for the actual domain experts. So here I'm referring to one of the specific scenarios. So the Beko company has this lockout, tagout procedures, also known as LOTO, which are procedures on how to shut down a piece of equipment or an entire production line in order to have maintenance intervention. And as you can imagine, you need to shut down properly for two reasons. First, because during the maintenance, nobody gets hurt. And second, because after the maintenance intervention, you want it to restart properly as well. So this is a very important procedure in companies. And so we customize the form that I showed you in the slide before to be more easy to use for these users. What means easy to use? First, use a language that is familiar to the users. So for example, we didn't simply reuse the labels of the concept in Pico because they may not be those that are really understandable by final users. You never need to show ontologies or URIs to users. You should not do that. Pico and the RDF is in the background. But use and customize, for example, here you see toggle diff referred to an energy point. Energy point is a concept that is specific to the user. They know what it means. Then how it is translated in the back is another thing. Second, we wanted to leverage the natural possibility of integrating knowledge thanks to knowledge graphs. So I think that this task that in Goblin relates exactly about interlinking. So we leverage this easy interlinking thanks to knowledge graphs. So for example, you see here of lock and PPE. PPE stands for personal protective equipment, like gloves, caps, and protective equipment that you use in a factory. And we had those little modules with types of locks, types of caps, types of gloves, which are in a specific knowledge graph, and we dynamically linked. So this drop-down list in the picture go and query the knowledge graph and return the information that is relevant for field, that specific field, and in the form. We use Garlic to do that. And so you customize also to include additional knowledge that may be used, reused, and facilitate the actual task for the user to fill in the form. And finally, various techniques to make the UI dynamically adapt to the needs of the users. So depending on what the user needs, the form maybe expands or because the idea is you don't have to overwhelm people with this thing. But I told you, so this was for the tacit knowledge collection, but I told you that we also did implicit knowledge extraction and collection. So this was also integrated in the same tool. So we had this artificial human intelligence pipeline where the user uploads a PDF file. The PDF file is sent to a knowledge extractor component that extracts the knowledge and pre-fills the form. Then the user goes to the form, which is pre-filled, does two things. And this is why I told you that it's always important to have human in the loop. First, because you need to correct what was incorrectly extracted, because this, of course, happens. You can see, for example, this example, you see that there is a table or a picture on the top. It may look like it's already structured data, but then understanding which piece of text or which images belongs to what part of the procedure is not that easy. And so an artificial intelligence may have a hard time in understanding that. So the first thing the user does is to correct what was incorrectly extracted. But then there is a second thing. Even those procedures that were already documented had a lot of tacit knowledge because they didn't explain exactly every single step. For example, they do not express some steps that are always done every time at the beginning of this procedure execution because they are considered common knowledge of the operators. So the other idea, the other task that the user should do is to complement with what is missing there. And the user can do it in this side-by-side interface where on the one hand they have the form, on the other hand they have the document and can check dynamically. We'll not talk about other things, but I just want to mention other things that we did around this. So validation and approval is not only correcting procedures, but in companies, you may have even multiple levels of approval. So once somebody writes the procedure, then somebody else, a manager, have to approve it, and another manager may approve the approval, and so on. So we, of course, also added this kind of validation, also validation across different procedures. We built a catalog for browsing and search across all procedures so that the user wants to know which are the procedure. For example, if they need to create a new one, maybe they want to start by duplicating an existing one or by copy pasting literally steps from one procedure to another. and still preserving the outcome. And then there are all the downstream application. As I said, I'm not going to tell you about them, but for example, we have this step-by-step guidance. So once you have the knowledge graph with all the steps and procedure, then you can build tools that help the user step-by-step to follow correctly the procedure execution. We tested these tools with the actual user of those 3 companies. And well, from the technical point of view, we can say that we were able to generate valid representation of procedures, but this was, let's say, by design of the tools. The feedback from the domain expert was really interesting. We were not sure if they would have felt, how can I say, overwhelmed by the task of inserting procedure, because it's a tedious task. You have to insert lots of things. But they were very happy because they were guided. So the fact that behind the scenes there is a conceptual model means that they are guided also step by step in documenting the procedure as well. And they reported that there was a better experience with respect to writing the procedure on paper or filling tables in Excel like they were used before. The other thing that surprised us was that the documentation of the procedure from scratch was much faster. So in the case of one of the companies, from 2 days to half a day, which is definitely a big improvement. Not only was faster, but the results were of much higher quality, because giving guided in how to fill it in, there were many more details. So the people who defined the procedure were less overwhelmed by the idea of structuring the knowledge and could concentrate in giving the relevant details. And why are those details important? Because then when you execute it, you have all the details you need in order to do that. So what are the lessons learned and what was next? So as you have understood from now, I'm really all about bringing research to concrete cases and solve real problems. So my first final slide is from research to industry. So what are the lessons learned of using research tools and methods, but to solve industrial problems? The first is that you need to get real requirements to make useful ontology. Some people said that the PICO ontology is not axiomatized enough, is too simple, and so on. But actually, the point is not to have a beautiful ontology. The point is to have an ontology that people can use and adopt in practice. And you can get to that result only if you get real requirements. The second thing is the level of abstraction. Again, the concept of PICO are in a sense shallow, but they are the level of abstraction correct for our goal, which was to describe procedures for people. So when you engineer an ontology, don't get lost in the superfine details. You can always extend more modules, more details later on, but the focus should be how do I respect and satisfy the requirements. Third lesson learned, this ontology really help. Not only help in structuring the knowledge, but helps in guiding people. So as I was saying before, some people have difficulties in conceptualizing or providing their own conceptual model. So if you have a conceptual model, you can guide people to make their tacit knowledge explicit, because you are already doing the hard work of conceptualization. This is another thing that is really important to me. The knowledge graph, the procedural knowledge graph that we developed are small. So each procedure is few hundred, or in the most complex cases, few thousand triples. I didn't say million, I didn't say billion, I didn't say gazillion. Those are small knowledge graphs. So we don't have any scalability problem in that. But is not the size that determines the utility, but the fact that those graphs are small, but contains exactly the knowledge required to solve a problem is what is really needed. And then you can go on in after some stages. For example, in one of the scenarios of the commissioning procedures, they started to fill in a few, and they said, okay, but it takes a lot of time to me to document everything. Then they saw the catalog with all the documented procedure, and they started saying, ooh, but if we have all of this, we want to document also the past commissioning process. Can we recuperate information from previous commissioning, previous procedures, and build a knowledge base of all of our knowledge? Because that would improve and allow us to solve other kind of problems. And finally, the point is always focus on what people care about. So both in ontology engineering, in knowledge graph construction, and in any tool building, you have to focus on what is the actual problem you are solving. I always say that ontology engineering is the art of distilling what is really important for people, and also what is not important for people. Because if you focus on what is important, you are doing 80% of the work. And if you focus on that, everything gets much, much smoother. So this was a very pragmatic lesson learned. I want to finish also with some more open research direction that comes from this even limited experience with this specific kind of knowledge. The first is the kind of knowledge that we deal with. So as I was saying, we deal mainly with procedural knowledge. We also dealt a bit also about causal knowledge, and of course there is descriptive knowledge. There is currently no framework to build and connect semantically those different kinds of knowledge, and this would be very interesting to evaluate and to explore. We focus on procedure for people mainly, but what we want to understand if the conceptual model and the interaction patterns during the procedure can be extended to human-machine processes. So for more generic socio-technical system and socio-technical workflows. Another important thing, you can interpret procedures as laws to comply with, or you can interpret procedures as policy and guidelines to follow as much as you can or as much as you want. For example, one important requirement that we got from users was, okay, I want to be guided in the execution of the procedure, but if I want to deviate, I have to be allowed to deviate. There are a million reasons why you want to deviate, because the conditions are changed, because there was error in the procedure, because you know best what is happening there. So there is a spectrum between prescription of procedures and the more autonomous decision-making, autonomous agent policies. And I think that also here there's a spectrum that is worth exploring. The other thing is, okay,
really quickly, we are a bit over the time,
yes.
so if we can summarize,
yes,
because
yes,
we will also have enough time for question answering. Thank you.
Yeah, it's the last slide. When in industrial settings, you tend to, sometimes you want to substitute people with robots, for example, for hazardous actions. Are the procedures defined for humans the same that can be defined for robots? Another thing, probably you know this better than me, there's a continuum between fuzzy and crisp knowledge. And finally, for all those tools powered by AI, powered by knowledge graph and so on, technical performance is not enough to be evaluated. You have to evaluate the people perception, the perception control, the trust, different cognitive factors. For example, we evaluated that people in industry are really really fear AI to substitute them. So this is something that you have to take into account when evaluating it. I just very quickly advertise with no shame that we will have a webinar, which is also related to this. PERCS is a very female-led project. There are lots of women in the consortium, surprisingly. And also this idea of, is this technology the same for men and for women? Is the technology the same for old and young and so on? Those are all other research direction that we want to explore, and we will have a specific webinar on the day after the International Women's Day to talk about women in AI and women in industry. So sorry for taking too long.